Hello, this is Dr. Prasad Putilam with the class video renewable energy resources. This particular topic, this is batteries. Okay, so batteries, lead acid batteries and lithium ion batteries are there in the syllabus of Srinivas University. Then comes the fuel cells, that hydrogen fuel cell is there, then biomass. So you see the battery, first one, that is lead acid battery. Lead acid battery, the working principle of lead acid battery, it operates through a reversible chemical reaction between lead plates and sulfuric acid as the electrolyte. You can see that later. You can see this is the setup of a lead acid battery. The schematic representation not exactly the same. You might have seen the battery which we used in our UPS, uninterrupted power supply. Such a type of batteries, that is lead acid battery. You see the lead plates are there, lead oxide plate grids are also present. We add sulfuric acid to that, therefore the name came as lead acid. Acid is the sulfuric acid. Okay, now the components, it consists of lead plate, that it is a negative electrode, that is anode. Negative electrode means anode, and lead oxide as the positive electrode, that is cathode. And these two electrodes are these plates what you have seen, those are the electrodes. They are immersed or dipped in sulfuric acid. Sulfuric acid electrolyte, the electrolyte sulfuric acid, it facilitates the movement of ions between the electrodes during the charge as well as discharge. Charge means when it gives electricity to us. Discharge means when we are charging it. Okay, so those two terms we have to remember. Then separator, we keep a plate of lead as well as another plate of lead oxide near to close to each other. They should not touch each other. If they touch each other, then the cross circuit will happen. Okay, so a separator needed, that should be pore. Ion should pass through that. Therefore, a porous separator which prevents the physical contact between lead and lead dioxide, their plates, but allows the movement of ions. Okay, then battery case. We need a case cover, a box to keep these items. It should be having strength and it should not leak. I should able to withstand the acid, the reaction of acid, sulfuric acid. You should keep the components properly inside that box. So it's a battery case. Okay, so this schematic diagram is given here, in which you can see the negative electrode anode. It consists of lead, spongy lead we call, soft lead. It is lead in soft mode, therefore the term spongy lead is used. It's not a separate element and all. It is soft in nature. Cathode, that is the positive side electrode. It consists of the grids which are filled with lead oxide, PbO2, and there are separators are there, and so many nodes are, anode and cathodes are arranged one after the other, and sulfuric acid is added to that. Now, what happens during charging and discharging? For that, I need to come out from this. Okay. What happens during the uh, reaction? What reaction takes place when a, okay, I think now it is visible. Okay, so towards the left side, I took it from the internet only, Google it. I just Googled it. Okay. So during discharge, means when it gives the work, let it reacts with the sulfuric acid. Sulfuric acid means H2SO4. H2SO4 means, that is the formula that we write as sulfuric acid, but always H2SO4 means that is H plus and HSO4 minus ion. It exists in a ionic state. Therefore, the HSO4 minus ions, it will react with the lead and become converted to lead sulfate, and one H plus remains because actually it is H2SO4, so one H plus remains there and releases 2 electrons. Lead oxide at cathode side, the lead oxide it reacts with the H plus and HSO4 minus and takes the electrons coming from the anode side and it become converted into lead sulfate and what therefore you can see during discharging time the net reaction is given here, that is lead plus lead oxide uh, uh, plus sulfuric acid, it gives lead sulfate plus I'll make it little bit bigger one, I think not able to see. Okay, now visible. Okay, so you can see that this is the reaction which takes place during the discharge. During charging the reaction reverses. During charging we know that this lead sulfate is there. Okay, so this reaction is incomplete. During charging the reaction reverses. When it gives electricity, it converts into lead sulfate. Lead sulfate and water is formed. During when we reverse the reaction, means when we charge the battery, that time lead sulfate it gives back lead as well as lead oxide. We just reverse this particular reaction. This particular reaction get reversed. Lead sulfate plus water gives back lead oxide and lead sulfate again gives lead. So lead and lead oxide goes back to the corresponding anode as well as the cathode side of the original battery. So that is the reaction. So reaction I have not given in the notes as such. That's why I took it separately, because reactions are not so important. That is important for chemistry people only. For an engineer, I don't think that you have nothing to do with the reaction. Okay, so the reaction not given, only the working principle is given. This is how it works. Lead acid batteries operate through a reversible chemical reaction between lead plate and sulfuric acid. Okay, so I'll stop this video here. Lithium ion battery, I'll take a separate video.